got a point source of gamma radiation placed 200 millimeters from the end of the Geiger tube, and the corrected count rate was measured to be 12.7 counts per second. We're now going to calculate the distance between the source and the tube for a corrected count rate of 20 counts per second. Okay, so let's jump across. And what I've got then is they've told us, here's my source, here's my GM tube, and the distance between there and there was 0.200 meters, and that was 12.7 counts per second. And what I want us to do is to find out where it would be 20 counts per second. Now, it's going to be closer. Has to be closer to get a higher count rate, so we want 20 counts per second. And we've got to work out what that distance there, r, is going to be. And we know gamma radiation in air, the intensity is proportional to 1 upon r squared. Now, what that actually means is the intensity times the distance squared is proportional to 1, which really is saying the intensity times the radiation squared is actually equal to a constant due to this relationship. So I can actually write then that I1R1 squared must be equal to I2R2 squared, because it won't change. And therefore, I'm going to be looking for this R2, so I'm going to use that as R2, that as I2, that as I1, and that as R1. And so I'm going to rearrange. So I've got to find R2. So R2 is going to be, I've got I1 R1 squared divided by I2, and I'm going to have to square root it to get to R2 on its own. Let's plug the numbers in. I1 we've got 12.7 times by 0.200 meters squared. And then I2, they've told us they want it to be 20, and therefore we've got to square root it. Taking that then, plug the numbers in. 12.7 times by 0.2 squared, divide that by 20, and then take the square root of it. Gives me an answer of 0.15937, it's a distance meters. Now, significant figures, 2 significant figures, 3, 3. So I'm going to go for 2 significant figures. So that's going to be 0.16 meters to 2 significant figures. Hope that helps. Thank you very much.